Okay. You see, okay, in this particular example, you have a sample of 6 DLSU site majors, and then the mean is 3. Now, imagine if you're going to get a different sample of DLSU site majors, okay? Another sample of 6 DLSU site majors. Do you think the average is going to be equal to 3? Chances are hindi na. Okay, mag-change na yung mean. So halimbawa, kuha ka ng sample of DLSU site major composed of Andrew, Atong, etc. Okay, letter A naman. The mean may not necessarily be equal to 3. So this is the reason why when you interpret the mean, it will always be in the context of the sample that you observed. So you say the typical score that we empirically observed in this particular group of 6 DLSU site majors is 3. That's your statement. Kasi if you're going to come up with a different sample, mag-iiba naman. Okay? So for this reason, when you use 3 as an expected score, you say the theoretically expected score for Mike as a DLSU site major is 3 based on the findings in this particular sample. So laging may anchor yung context ng sample, because if you change the sample, there is a possibility that the mean will change. That means there's a possibility that the rest of the values from deviation from the mean, square deviation from the mean, sum of square, variance, standard deviation, they could all change. Kasi nga nag-iba yung mean. Okay? So degrees of freedom is going to tell us the number of observations that we allow to change freely when we come up with another sample. So in this case, the formula tells us, okay, the degrees of freedom is 5. So it says here, if we are to come up with another sample, we can allow 5 out of the 6 observations to be different. Okay, so in this case, 5 out of the 6 values here can change when we change the sample, but 1 has to be fixed. Dapat yung isang value dyan, okay, theoretically, we don't know which value, but at least 1 value dito is going to be the same as the value in another sample. Okay, so to make the story short, think of a population. Okay, and this population represents pepperoni pizza. Okay, it's a population of pepperoni pizza. Of course, okay, in this pizza, okay, you don't just have pepperoni in it. Okay, you also have cheese, pineapple, anchovy, mushroom, tomatoes, bell pepper, arugula, ano pa ba, olives, okay, and so on and so forth. Okay. So, you could even put daing if you want that, okay, daing pizza or longganisa, something like that. You know, diba? We can always create new ingredients. But the thing is, okay, whatever the other ingredients are, okay, we know that this is a population of pepperoni pizza because there's always pepperoni in it. Okay, so far so good. So if we're going to come up with a subset of this population, okay, we call it a sample with a sample size of 6. So imagine it will have 6 ingredients. Okay. So what happens now is when you randomly select, okay, ingredients, let's say you got cheese, pineapple, okay, mushroom, tomatoes, arugula, and pepperoni. It is the pepperoni that will make this sample a pepperoni pizza. Okay? Now, if we're going to get another sample, okay, change the sample, get another sample with 6 ingredients. You could have cheese, anchovy, arugula, but again, you know for a fact that this is going to be a pepperoni pizza because you have pepperoni. So what are we saying here? That 5 of the ingredients are free to change except for 1. And that 1 ingredient has to be the same across different samples. And that one is the true score. The one that will really make the sample, the slices or the pizzas pepperoni. So the true score should always be found in this sample, in the rest of the other samples, and there's only one true score. So n minus 1. Okay, the rest of the ingredients can change, but the true score, the one true score that is in the population, will always be found among these samples. And that is what we mean by the degrees of freedom. Okay? And we only use the degrees of freedom when you're analyzing samples. So notice in our table a while ago, okay, we use the degrees of freedom when we are getting the variance, for the variance. But if you're dealing with the population, you don't have to use the degrees of freedom because you're practically dealing with all the members in that population. Okay? You only use the degrees of freedom in analysis of samples. Ayun. Tadaan! Degrees of freedom. Okay, daming sinabi. Okay, so far so good. Are there any questions before we continue? Give me a sign, please, if we can proceed. Okay, dokie. Okay. So before we proceed to a new topic, okay, let's try to understand how we can possibly use descriptive statistics. Okay. This is an introduction to your statistical literacy. Okay. When we speak of statistical literacy, you understand what you are reading. Okay. You can actually make deductions or extrapolations on what you are reading. Okay. Now, the thing about this is that when you read statistical reports or journals in psychology, okay, researchers often describe their data using only 3 values: the sample size, the mean, and the standard deviation. Okay, so based on our example, for instance, okay, you might say, in this study, we observed the meaning in life scores of 6 DLSU site majors. Open parenthesis, M equals 3, comma, standard deviation equals 1.41. You see, as much as possible, statistical values are presented within parentheses. Okay, so statistical results are often presented within parentheses like this. Okay, so this is a typical APA style of writing when you describe your data. Okay, notice you only have the sample size. We have 6 here. You have the mean, 3, and the standard deviation of 1.41. So let's go back to measurement. In measurement, you have to have the 3 elements. Element number 1, object. So it's pretty clear here that your object would be DLSU site majors, a sample of DLSU site majors. And that sample has 6 elements in it. Okay, so this is your object, 6 DLSU site major. What is the property that you describe? Meaning in life. Okay, and the attributes are actually scores. So meaning in life. Okay, so this is the property, meaning in life, and the attributes that you use are scores on meaning in life. And how do you describe the meaning in life score of the 6 DLSU site majors in your study? So the attribute is now the mean, the true score. Okay, so in this case, you now see it's the typical score that you observed in this sample of DLSU site majors is 3. So notice you don't actually write it this means the typical score that we observe in this sample is 3. You don't write that. You just simply reported mean equals 3. If you truly understand your statistical analysis, you know what this mean represents. Diba? Simple sentence lang. So you don't come up with a paragraph and say, in this study, we observed the meaning in life score of 6 DLSU site majors, mean equals 3, standard deviation equals 1.41. This means that the true score in this sample is 3 because the typical score that we observe in this sample is 3. Then, redundant ka na. Okay? It's you who knows statistics should be able to understand what the mean will represent here. So this is the reason why if you have this table, these are the meanings of the mean. And then, ang dami niyang posibleng meaning. Hindi mo ito susulat sa report mo, this should happen at the back of your head pag nabasa mo ito. Okay? I hope this is making it clear sa inyo. I hope you will be able to apply this later on. Ito pala yung sinasabi ni Sagit pag nagbabasa ng journals. This will teach you how to appreciate journals more. Okay? So far, so good on this. Okay. Uy, walang nagtuturo na. Okay. Aren't you glad you're in this difficult class? Joke lang. Okay, next you have the standard deviation naman. Okay, so how do we understand the standard deviation? Okay, so understand that the standard deviation is an extent. So this is how we represent an extent. Okay, so if the standard deviation is 1.41, this is 1.41 units. Okay, so it's an extent, okay, that has 1.41 units. So kumbaga inches yan, this is 1.41 inches. Okay, if your units would be in feet, this will be 1.41 feet. Are we clear on the representation of the standard deviation? Okay, so let's visualize now. So given this simple statement, you can actually visualize your data. So notice wala na yung data mo na 1, 2, 3, 3, 4, 5. You don't report that. So when you read journals, ito lang talaga yung makikita mo. So the question is, ano ba yung actual data? Ano yung mga actual scores ng mga 6 participants na yan? So this is the time that you will extrapolate or make deductions. Here's how you could use it. Okay, imagine a number line. Okay, so iyan muna natin to. Okay. Let's just hide this muna. So first step, okay, imagine a number line, okay, which has intervals, okay, and then the mean is equal to 3. So imagine that the center of the data is 3. So you expect every BLSU site major, or at least majority of the site major, to have a score of 3. Okay? So you're practically saying that the typical score of a DLSU site major on meaning in life is equal to 3. Ito yung true score niya. Okay? This is the theoretical na. So you say, we expect every person in this group to have a score of 3. Okay, now, standard deviation. You use the standard deviation to make an inference about the actual score that you observed in this sample. So ano yung actual scores ng 6 DLSU site majors na yan? But because you don't have access anymore, this is how you could possibly estimate it. Remember, one standard deviation is 1.41 units. And the standard deviation can be below and above the mean. So when you say below the mean, that would be standard deviation minus 1.41. That will lead us to a score of 1.59. Okay? And then one standard deviation above the mean, okay, would give you, okay, a score of 4.41. Okay, that's mean plus standard deviation. So if all the conditions are correct, then you could say that 68% of the participants in this group must have had a score between 1.59 and 4.41. You get the point? You don't have the actual scores. Okay? But if all the conditions are correct, then you can actually make a deduction. You can extrapolate information from these three simple values and say, mga 68% of the participants in this sample had a score between 1.59 and 4.41. Okay? So if you look at the actual data, okay, sino yung pasok between 1.59 and 4.41? Ito, pasok yung scores nila. 2, 3, 3, 4 are between 1.59 and 4.41. That makes it 4 out of 6. So what is 4 out of 6? That is about 67%. Diba? Ang estimate natin about 68%. Of course, yung estimate mo becomes better if you're dealing with a larger sample size. But in this case, malapit-lapit na. So you're saying majority of the participants in this sample must have had a score between 1.59 and 4.41, or about 68% of those participants. Okay, do you get it now? How to use the standard deviation, okay, in making sense out of whatever data you have? Imagine, di ba, 3 lang yung values na binigay, pero you can make a lot of deductions if you understand your stat. Here's another. Let us pretend we add one more standard deviation below the mean. So we're now talking about 2 standard deviations below the mean, which leads us to a boundary of 0.18. And add another 1 standard deviation above the mean, which could actually lead to a score of 5.82. Okay? So this, if all conditions are correct, this would cover about 95% of your data. So about 95% of your data will tell us that, okay, the participants had a score between 0.18 and 5.82. If you look at the sample, that practically covers all the data that we have. 100% na yung cover. Okay, of course, okay, we just estimated it as 95%. Okay, the conditions are not perfect here, but the larger the sample size, the more likely you'll be precise in your estimates. Okay, and then later on, 3 standard deviations below the mean, okay, that will lead you to a negative value, and 3 standard deviations above the mean, that will lead to a 7.23, and that would be 99.7%. So you're saying that if all conditions are met, 99.7% of my sample size will have a score between negative 1.23 and 7.23. Okay? So this is one way at how you can possibly make inferences or make deductions or extrapolations about these values. So notice, you just present one sentence like this. You don't actually say, this means that 68% of my participants must have had a score between 1.59 and 4.41. You don't say that. Ito lang ang simple sentence na i-report mo. But because you understand statistics at the back of your head, you can make this extrapolated information. Okay? So, ma-feel nyo na Sherlock Holmes kayo. Diba? Nakikita mo yung implication ng data ng state sentence na yan that an ordinary person will not see. Galing, no? Saan nang galing itong 68%, 99.7%? Okay? If you want to read more about it, search for the 3 sigma rule. Okay? Yeah, 3 sigma rule. We're gonna talk about this when we go to the normal curve. Okay, the 3 sigma rule. Okay, we're gonna revisit this later. Okay, so this is one way at how you could read it. Okay, another. Okay, notice. Okay, in this table we computed sum of squares, we computed degrees of freedom, etc., other values. But you only report 3 values. Okay, why? Ano yung degrees of freedom dyan? Hindi naman sinabi, pero you can always get the sample size minus 1. The degrees of freedom here is 5. That means, okay, if I'm gonna come up with a different study using the same sample size, 5 values are free to vary. Okay, except for 1. What is that single value? It's the mean. Okay, a score of 3. Okay. What about the variance? How come we did not report the variance here? You did not report it because you can compute the variance at the back of your head. Just get the squared value of the standard deviation. Okay, so this is what happens. Okay, so in this study, we observed the meaning in life scores of 6 DLSU site majors. Mean is equal to 3, as standard deviation is 1.41. Yun lang, wala nang ibang information. But how do you use this? Okay, to describe, let's say, let's come up with Manuela. Okay, so let's describe Manuela. So you say, well, as a DLSU site major, we would expect Manuela to have a score of 3. Ayun, yung based on the mean. Okay, as a DLSU site major, we would expect Manuela to have a meaning in life score of 3. So let's imagine that score to be the center. The question is, what was Manuela's actual score? What was Manuela's actual score? Okay, it's not reported here anymore. So we make a deduction using the standard deviation. Okay, let's say if Manuela's score is above mean, okay, her score, okay, could be, okay, 1 standard deviation above the mean. Okay, so ganito siya, extent. Remember, it's just an extent, the standard deviation extent. So, okay, usually, okay, you refer to it as 2 standard deviations. 1 standard deviation above and 1 standard deviation below. Okay, and based on our estimates, that will be 1.59, okay, and 4.44. That's 68%. So you could say, I'll be 68%. Okay, there's a 68% chance that Manuela's actual score will be between 1.59 and 4.41. So you can, based on the 3 sigma rule, you can make some kind of a prediction, an inference with probability. There's a 68% chance that Manuela's actual score would be between this and that. Okay, parang ganon. So you could actually use the 3 sigma rule. There is a 95% chance that, okay, Manuela's score would be between 0.18 and 5.82. Okay, so para sinasabi mo, I would be 68% confident that Manuela's score would be 1.59, 4.41. 68% confident ka lang. Dagdagan mo naman yung confidence mo. Sige, kung dadagdagan ko yung confidence ko, I'll be 95% confident that her score would be between 0.18 to 5.82. Tinawak mo yung possibility, yung range. Okay, so what was Manuela's score? 4. Okay, pasok sa 68%. Okay, mas pasok siya sa 95%. Okay, so that's how you actually look at this. Now, since we know that Manuela's score is above the mean, you could actually just put it there. Okay, so parang ito yung representation ng mean and standard deviation. This is the expected score, and this is where the actual score of Manuela is. Okay, or even 2 standard deviations. Okay, standard deviation. Now, notice there's no variance, but when you compute the variance, okay, you're just simply getting the squared value of the standard deviation. So if you get the squared value of the standard deviation, then nagiging variance yan. You represent it as an area. Okay, so you're saying now that, okay, the true score of Maria is 3, pero her actual score could vary by this amount. Okay, so notice the difference. If the true score of Maria as a DLSU student is 3, her actual score must vary by this extent. Okay, standard deviation. If you're referring to the variance, if Maria's true score as a DLSU psych major is 3, her actual score could vary by this much. So notice the variation is being represented in the form of an area. Okay, how is this being used in psychology? If the variable is meaning in life, this is the size. This is how large meaning in life is that you would observe from every DLSU psych major. Kasi variance is average per one DLSU psych major yan. So you're practically saying, this is the size of meaning in life that I would typically observe from a DLSU psych major. So notice, wala nung variance yan. Okay, compute mo yung variance and alam mo yung meaning ng variance, then you can make all this information. Sum of squares. Ano yung sum of squares? Well, if you multiply the variance by the degrees of freedom, remember, kailangan alam mo balikan to. So multiply the variance by degrees of freedom, you get the sum of squares. Okay, and the sum of squares basically represents the totality. So all the participants here represents the sample, and this is what we're saying. This is the total amount of variation that we observed in this sample. Total amount of variation from the mean that we observed from the scores of the participants in the sample. Ang haba ng sentences, no? Okay. Total amount of variation that you observe. Total amount of variation from the mean that you observed from the scores of the participants in the sample. How do we use this in psychology? We usually represent this as the size of meaning in life observed in this particular sample. Gaano kalaki ang meaning in life na na-observe mo sa sample na yan? Sum of squares. So you see, okay, each value that you encounter here has an implication in your understanding of psychology later on. But what you report, what you read in journal articles would be the bare minimum, just sufficient information, but because you have statistical literacy, you can make extrapolations, deductions from whatever is being reported. That will set you apart from an ordinary person. Ta-da! Okay, so hopefully, okay, with this demo lecture, you can complete this table, understand the terms, the concepts, okay, and this is one way of how you can possibly use basic statistics to make extrapolations, okay, extrapolations, etc. Mababasa mo ba ito sa books? Okay, the way I integrated this, hindi. Sorry for that. Okay, so you listen carefully. And hopefully one of you who knows, maybe Francis will be writing a book in the future about this. Just mention to me, ha? Okay. According to my teacher, diba? Wala pang book na ganitong magsulat. Maybe when I retire, okay, I'll write a book. But walang pera sa books. Kaya, sige. walang pera sa books, lalo na pag Filipino author ka. Your co-Filipinos will not buy your book. Okay? We prefer mga foreign-made books pa din. Diba? Buti pa sa India. Okay? So, at any rate, sa India ginagamit nila books written by Indians. Okay. Anyways, any questions on this before we continue? Please turn on your webcam.